Okay, hello, good morning. I am R.Goutham from the Department of Electrical Electronics Engineering. Today I am going to handle different type of single phase induction motor. First we are going to discuss about the split phase induction motor, in which a single phase is converted into two different phases so that we can able to make the machine to start from the initial zero condition to the sub-synchronous speed. So first we are going to discuss the split phase induction motor. So as you see here in the given diagram, we have rotor and stator. In the stator we have main winding and starting winding. Based upon the properties of these two winding only, the motor start to rotate. So let us see how and what are the characteristics of these two winding. So a split phase induction motor is provided with an auxiliary or starting winding with additional to the main winding or running winding. Okay, so here the starting winding is 90 degree with respect to the main winding, okay, during the operation. So what are the condition is, the starting winding has high resistance and low reactance, and the main winding has low resistance and high reactance. So we can say that initially due to this, what happened, the starting winding, the current IS is flowing, the main winding, the current IM is flowing. These are the two derivative of the main current. So initially a single phase supply is applied at the input side, phase and neutral. This current split into two different IM and IS. So with respect to the phasor diagram, we can see here, this is the main current in the main winding, and this is the current in this starting winding. And the vector relation of those two currents, the current to the main winding and the starting winding is the main current. And you can see the difference between the phase of IM and IS is alpha, and the phase difference between the main voltage and the main current is phi. So why it is like this? Because the main winding has highly inductance. Highly inductance, whereas the starting winding has high resistance. So due to this property only, both current are leading and lagging with respect to the main current. So this is the construction detail and the phasor diagram representation. And one more part in the construction detail, we have a centrifugal switch which will be opened when the rotor attain 75% of synchronous speed. After that, what will happen, the centrifugal switch is opened and the main winding will be cut off, and all the current will flow through the main winding, so that this rotor or this machine will operate up to 1500 rpm. So this is how the motor is rotating. So now let us see the operation. So you see here, when two stator winding are energized, okay, how it is energized? From the single phase AC supply, we are going to give the input voltage. From this, the current is flowing through the two winding. So single phase winding has the main winding which carries the current IM, as we have seen in the phasor diagram. Similarly, the current flowing through the starting winding is IS. So as we discussed earlier, that the main winding has high inductive, so that's why it is lagging, and the starting winding has highly resistive, so that's why it is leading with respect to the main current. And the angle between the main current and starting current, this is between 25 degree to 35 degree, as we have discussed in the phasor diagram. So what happened, due to this, a weak revolving field is generated just between these two phases, and the total starting torque generated here is Ts equal to K into Im, Is and sin alpha. So sin alpha is nothing but the angle between Im and Is. Okay, va? And K is the constant which is dependent upon the design of a motor. So as I told that when the motor reaches up to the 75% of synchronous speed, the centrifugal switch is open and the circuit isolates the starting winding, and actually the starting winding is used to make the motor to start at the initial condition. After attaining the 75% of the synchronous speed, it will be cut off by the help of centrifugal switch, and all the current will flow through the running winding, and it will start to rotate in the normal condition, which is the speed below the synchronous speed. It depends upon the amount of load is used. And what are the character is, the spinning torque is up to 1.5 to 2 times the full load torque, and the starting current is 6 to 8 times of the full load current. Okay. Due to this, what happened, the cost is low, because since we are not during the operation we are not using both the winding, only one winding is used. Initially starting winding used, and it is cut off by the help of the centrifugal switch, and finally all the current flow through the main winding. So what happened, it is most popular induction machine, single phase induction machine used in the market. And you can see the speed torque characteristics. So this is the speed, this is the torque. So initially this is the starting torque. So this represent 1.3 times and increases up to the maximum value T max, and attain to the speed equal to the synchronous speed. Okay. And you can see this, since the starting winding is made with a fine wire, okay, hence the amount of current flowing through it should be reduced, so that the current density is very high. So to reduce this, we need a built-in relay, so that we can able to protect the winding, okay, at the initial condition. Okay, and you can see that since it is running at the below the subsynchronous speed, that is almost equal to constant speed, that is the speed variation up to 2 to 2.5% of the full load current, that is in between 1100 rpm to 1450 rpm. Okay. So it is used as a constant speed motor, and the general rating of this machine is 60 watt to 250 watt. Hence it is used in the application like fan, washing machine, oil burner, centrifugal switch, centrifugal pumps, and small machine tools. So this is the theory, operation and construction detail regarding the split phase induction motor. I hope you understand the concept here. Thank you, students.